Okay, so let's look at cross-validation. So what do we mean by cross-validation? One of the big problems with everything we've done so far is our models can get very good at prediction for the data we give them. They can often do what we call overfitting, and by overfitting it means that your model is almost perfect at predicting for the data you've given it. But if you think about what we're trying to do, we're trying to predict for new data. And if your model becomes too precise to your data that you've used to create this model, it becomes rubbish in the future. So we need to think of a way that we can somehow get a good sense of how good our model will do on new data. And that's what cross-validation does. So the idea is that what we're going to do is we're going to take our data and we're going to split it into k pieces. And then what we'll do is we will take k-1 parts, choose our model, or have any model that we're interested in, train it on that data, and then fit it to the bit that we didn't use. And we're going to do that again and again. And each time what we're doing is we're avoiding what we call data leakage. And by data leakage, I'm not saying that we get too much information about the new data from the model we use to train. So let me illustrate here. So here's all my data. Each row is all my data, and I've split it into 5 parts in this case. This is 5-fold cross-validation. And what I do is I will use these bit of the data, these 4 bits, to train my model, and then I'll use it to predict the test and say, how good did you do? Now repeat it again. I use these 4 bits to train all together, put them all together, fit my model, and then I go and predict for the test. So let's assume that we've got k parts, which we'll label C1 to Ck. I'm going to let the number of observations be nk, and we'd like that to be about the same each time if we can. So altogether, our total number of observations is we just add up these parts. And then what I can do is I can calculate my mean square error for the kth part, which is the difference between my observed value and my model, where the model has been fitted using all the data except for that kth part. And I'm actually looking at how it does on this. So this is going to be the test data. This was created using the training data. Again, we're using the residual sigma square, so we take the square distance, but we could use other things. We could use the MAE and all those. We divide by how many, and that will give us the mean square error for the kth fold, and repeat that, and then we put them together, adjusting for the size, and that will give us our k-fold. So the whole idea is we split it and we put some data aside, we fit, we see how well it does, and then we repeat this altogether k times. So that's it. I'm going to show you actually how to do that. I mean, the theory is sort of like, yeah, okay, what's that? But go to the case study where we actually step through all these things and you'll see what we're actually doing. It will make more sense. And next time we'll do ridge regression.